everyone once again. It is an honor and pleasure to be with you here this evening. My name is Engineer JIBRIL ABDULLAHI BALA. I'm a visiting senior research fellow with Summit University Offa, and I'm also a faculty member with the Department of Mechatronics Engineering, Federal University of Technology, Minna. I think the host needs to give me permission to share my screen so that we can begin. The meeting host, please, if you can hear me, you need to give me permission so that I can share my screen.
You have the permission, sir.
Okay. I still cannot share. Can you make me a co-host? Maybe that would, if you can make me a co-host, I think that would also help, because currently I cannot, okay, now it's, okay.
Making a co-host, please.
Yes, they've done that. So I'm trying to share the screen. Okay, so can you see my screen?
Yes, you can, sir.
Okay. So today we'll be going through the introduction to artificial intelligence. From the course schedule that we have, this week is supposed to introduce us to artificial intelligence and also some fundamentals in Python programming language, such that later on, with our knowledge on AI, some knowledge in Python and some knowledge in MATLAB, we can implement some AI techniques hands-on. So today I'll be taking us through the introduction to artificial intelligence. Then on Wednesday, Engineer Adeyinka Adedigba will be taking us on the introduction to Python and how it can be applied to AI. So AI is a term that we hear quite common, especially if you are in the computer science field, mathematics field, or engineering field. And even if you are not in any of those fields, if you go on YouTube or you watch TV or you watch the news, in some form or another, you would hear people talking about AI. Before I continue, is my screen changing? Okay, I think. Okay, let me try this again. Okay, can you see my slides? You should be seeing artificial intelligence.
Yes, sir.
Yes, sir.
Okay, thank you. So we've been hearing about AI. One way or another, you must have heard about AI. But some of us might wonder, what is this AI that people keep talking about? Well, AI, the term artificial intelligence, was first developed by a man called John McCarthy. And the whole idea behind artificial intelligence is that we can develop intelligence in machines that are on the same level as the same intelligence that we have in human beings, or even more than human beings. Now, when I talk about intelligence, some of us only use the word intelligent to describe a smart person or a brilliant person. But in this context, what I mean by intelligence is any kind of thinking faculty that a person has. That is what we are trying to replicate in computers. If you can see a chair and identify that this is a chair, then AI tries to put that same feature in machine such that if a machine also sees a chair, it can tell you this is a chair. If you are going down a path and you want to take a shortest path to a particular destination, then we should be able to put that same kind of intelligence in machines as well so that they can take that short path. So AI mainly is a subfield of computer science that aims at building computer systems to perform tasks that humans would, that require human intelligence or even exceed human intelligence. But AI has been used even outside computer science. As a matter of fact, in the world today, there is no field that has not implemented AI in one way or another. No field. So if you feel that you're in social sciences or you are in the arts or you are in, let's say, law or medicine, AI has been applied in all of those fields in one way or another. Even in linguistics, even in English language, AI has been applied. So more or less, although it's a subfield of computer science in context, AI has been applied even outside computer science. And of course, AI was first introduced in Dartmouth College in 1956. So more or less, AI machines behave like how we humans behave. As a human being, we have 5 senses, right? We can see, we can smell, we can taste, we can feel, and we can hear. Now, based on those senses that we have, you take in anything from the environment, right? You see things, you hear things, you smell things. But based on those things that you perceive, that would determine the kind of decision you are going to take. If you are walking down the road and you see a stone in the middle of the road as an obstacle, it will register to you immediately that this is an obstacle to my path. I need to go away from the obstacle to continue. So it's the same context with machines. In machines, we want them to perceive the environment. But in this case, they are not perceiving using eyes and ears. They are perceiving using what we call sensors, right? They can sense the environment and then they can take decisions. Now, these sensors can measure anything. They can measure, you have sensors that can measure temperature. The same way you feel hot or cold, then a system can feel hot or cold. You have cameras, which are also sensors, vision sensors, that can see things just the way we human beings see things. You also have sensors, that can smell, right? And you also have sensors that can detect gases just the way we detect. So you have sensors that you can even detect touch, just the way we feel things. So these sensors give input to the computer. And as human beings, when we take the input, our brain processes it before we take an action. So the brain in the computer, in this case, will be the artificial intelligence before the machine takes an action that can optimize their level of success, that can take the best decision that they want to take. Now, these artificial intelligence systems, you use AI to make a system intelligent. And that's what we can see on our screen today now, intelligent systems. So when you hear that a system is intelligent, it means that AI has been infused into that system to make it intelligent. Now, intelligence itself takes 4 major things. If a system can exhibit these 4 things, it means that system is intelligent. The first, the system should be able to learn. The system should be able to learn. Okay, I think the slide is not changing. So what I'll do is maybe I'll take it out of the slideshow, and I'll just run it directly without putting it in slideshow. Okay, so can you see intelligent systems?
Yes, sir.
Okay.
Yes.
Okay, thank you, sir. So intelligence, basically, when a system exhibits these four things, it means that that system is intelligent. First, the system should be able to learn. What do you mean by learn? When a system is able to learn, it means that when it sees something, it can, reason and understand that thing, and then use that knowledge to take a decision later. That is the point of learning. A system should be able to understand. These sensors that we talked about, when a system takes information from these sensors, the system should be able to understand that information that it has taken. Number three, the system should be able to solve a problem. If it encounters something that will be an obstacle to its success or its goal, it should be able to know how to navigate that particular thing to reach its desired goal. And lastly, the system should be able to make decisions on its own without human intervention. Those four things make a system intelligent. And you can make systems intelligent by applying artificial intelligence techniques. Now, let us take an example, because a lot of us make a mistake when talking about AI. When a system just does something automatically, we just say the system is intelligent. Or we just say, I want this system to have AI. And maybe what we are even talking about is not AI. Maybe we just want something to be automatic or automated. Now, for instance, if you go to these supermarkets or these big departmental stores that have sliding doors, that when you come, the door opens for you and you leave, the door closes. That system is not necessarily intelligent because, number one, the system cannot learn. It cannot learn in the sense that ideally the system is supposed to open the door just for human beings. But when the sensor detects movement, whether it's not for a human being, it's going to open. So the system doesn't learn anything. And that motion that the sensor detects, the system doesn't understand whether it's a human being or a dog or a bird. No. Once it just sees motion, it's going to open the door, right? So even from that alone, you know that learning and understanding are out. That system is not intelligent. It's just automatic. Once it senses, it opens the door. After some seconds, it closes the door. That system is automatic, right? If you have a drone that you control manually with a control pad or a remote control unit, that drone is not intelligent. More or less what you are doing is you are controlling it. Now, also, if you have a system that, like all these factories that we have, that something will be moving on the conveyor belt, something will pick it up, drop, put something inside. That system also is not necessarily intelligent. That system is automated. So there is a big difference between intelligence and automation. So for a system to be intelligent, it needs to learn, it needs to understand, it needs to solve a problem, and it needs to take a decision. Now, let me give you an example, right? If you have a system that says, okay, you've infused AI in maybe a robotic system, and you want it to move from point A to point B. Now, if the system is moving on its own, if you've not given it a map before, all you want is the system to use cameras to identify its environment and move, already that system is learning, and that system is understanding the environment. Once the system comes across an obstacle and it's able to dodge that obstacle on its own, that system has solved the problem. And the fact that it even dodged the obstacle, that it took a decision to dodge the obstacle, that system has made a decision. So that is an example of intelligent systems. Are you still with me?
Yes, sir.
Okay. If you have any question, you can drop it on the chat box, or you can save it to when we have the question and answer segment. So from intelligent systems, if you look at the diagram, we've had three major eras in terms of computing. Like starting from the 1890s to the 1940s, we had the tabulating era, where more or less what they used were punch cards to control computers. Now, this isn't intelligence. This is basically operating a computer using punch cards. Now, in the 1950s to the present era, we have the programming era, where people write codes that automate some processes in computers. But starting from 2011 till date, and even after 2011, we have the AI era, where you don't necessarily have to exactly tell the computer, this is what I want you to do. You can give it information for it to learn, and it can take that decision on its own. It's more or less like what we do in our classrooms, right? You have what we do in our classrooms. You have the class, the first class, where you are taught something, right? They teach you the fundamentals. After they teach you the fundamentals, then in the test, they'll give you something more advanced than the fundamentals. Now, after that, in the exam, that's in the test, then in the exam, they'll give you something more advanced than the test. So you see, in that kind of situation, you are learning, right? You are not necessarily told exactly how to solve the questions in exams, but based on what you learned initially, you were able to deduce and solve these questions. So it's the same thing with intelligent systems. Now, we're talking about intelligent systems and AI, but how many types do we have? Well, more or less, we have two. We have the strong AI. Now, that strong AI, more or less, is the type of AI that we see in movies. The strong AI is the type of AI that we see in movies. Now, in movies, you see some robots or some so-called artificial intelligence that can do basically anything. For those of you who have watched any of these superhero movies, like these Marvel movies, think something like Jarvis, what Iron Man has, is more or less an example of strong intelligence. You have a system that can do more or less anything for you. Just like how a human being reasons and a human being thinks, that is how you have that system. And that is what strong AI is all about. Now, you have examples like the DeepMind and Human Brain Project, and even the most recent one, ChatGPT, that everyone is talking about, is an example of strong AI efforts. But also, you have what is called weak AI. And here in weak AI, you have AI systems that can perform just one or a few specific tasks correctly and accurately. Examples are chatbots. Chatbots can only answer questions within a specific domain. If you've used the chatbot before, you will see that the more you ask it questions, it gets to a point that it comes back to the same answers it has given you before. So, but in reality, currently, we have AI that is between strong and weak. Currently, strong AI is still theoretical, although there have been many efforts to develop systems that exhibit strong AI. And I think the closest we've come so far is the ChatGPT that we have now. But weak AI is what we have generally. So currently, AI is between strong and weak. That is a natural language processing and natural language generation. Okay, you have NLP, natural language processing, which is broken down into generation and understanding. That natural language processing is more or less making machines understand the way we communicate as humans. So for them to understand what we say is natural language understanding, and for them to respond and give us information is natural language generation. Are you still with me?
Yes, sir.
Okay. Please just give me a second. Let me change my source of power. Okay, I'm back.
We can start asking our questions. You can put it on the chat box.
Okay. So now we've talked about the types of AI. What can we even do with AI? So this is what brings us to the multidisciplinary applications of AI. Now, like I said earlier, you have many applications of AI, irrespective of the field which you are in. You have many applications. What I have here is just a few of the common applications, right? So here I said AI research uses techniques from many fields, such as linguistics, economics, and psychology. You know, AI itself, I just talked about natural language processing, has been used in linguistics in English. I was involved with some people that wanted to develop an AI system that can translate what a person says or any write-up or information into our local tongues here in Nigeria. Now, how this is actually different from Google Translate is not that they're just trying to translate it to Hausa, Yoruba, or Igbo. They are even targeting the dialect where you are from. So, for instance, if you are Yoruba and you are from Ilorin and you speak a different type of Yoruba from the person in Ibadan, that AI application would translate that information to your particular dialect, depending on what you want. So AI has been used in linguistics. It has been used in economics, to make predictions, to develop economic models that can make predictions based on data, and psychology as well. So AI has been used everywhere. Now, some of these common techniques that have been used are control systems. More or less, when you talk about control systems, what you are talking about, well, in layman's terms, you are talking about systems that can behave in a certain manner, but they've been mostly applied to automated systems like robots, like self-driving cars, like drones that are not controlled by people. So those are control systems. They help in the navigation and the rest. The natural language processing, as we talked about, facial recognition. For those of you that have phones, smartphones that use face lock, it's an application of AI where after you register your face using it for the first time, subsequently you can put your face back on and it will identify you. Sometimes even with glasses, sometimes even with your beard, for the men, maybe after you've grown a beard, it will still recognize you. Or maybe you have the beard and you shaved it off, it will still recognize you. So those are applications of AI. You also have speech recognition. For those of you who use iPhones, Siri. Siri is the voice command for Apple products. And more or less, if you are not, once you register with Siri for the first time, if anyone else tries to use Siri, it doesn't work. It has to be you, the owner of the phone. So that is speech recognition. Then you have business analytics. For those of you into crypto and Forex, you always have some people who give you tips on how well the market is going, when this particular commodity is going to rise or fall. It's not that they have knowledge of the future. It's not like they are psychics. They use AI. They have certain indicators that they look at that the machine can predict when this would rise or this would fall. You have pattern matching. For those of you who use fingerprints on your phones or biometrics when you come to the bank, once you register your fingerprints or biometrics, if you come again and you use that, it will detect it. It's more or less AI. Then data mining, searching for data online, in stuff like web scraping and the rest. So these are many techniques that have used AI. Now, these are just general applications or techniques at AI. Let's look at specific applications. If you look at transportation, AI has been used in autonomous vehicles. Autonomous vehicles is actually one of my areas of interest, and we've used AI a lot in identifying road anomalies like pothole and speed bumps automatically without human intervention, or even navigating a road, getting to a particular destination without human intervention. You've used it in unmanned aerial vehicles. We know them popularly as drones, and unmanned ground vehicles like mobile robots and the rest. Then for home automation and services, Amazon uses delivery drones. So that uses AI as well, getting to the destination, knowing where to drop the package. Then you also have vacuum robots. There are robots that you can just drop on the floor and it will go around the room vacuuming, some sweep. So you have those kind of robots. And you even have some of these robots in warehouses where they can move automatically within a warehouse to pick up or drop something. Then you have personal assistants. This is similar to Siri that I was talking about, or Alexa, virtual personal assistants that use AI to answer your questions. Then in healthcare, AI has been done a lot in terms of prediction of diseases like diabetes and even diagnosis of diseases. Engineer Adeyinka Adedigba that will be taking us on Wednesday has done a lot in medical AI. He has used AI to identify COVID, to identify breast cancer and the rest. So AI has been used a lot in there. Then you have education as well, interactive machines where based on a particular request or question, the system can give you a particular personalized answer for you. Then in terms of security and defense, there are AI techniques using surveillance drones, similar to what the Air Force uses, and also AI for algorithms for fraud detection, which is mostly utilized in banks and financial industries. When the AI flags a particular transaction, then they send it to a higher up person to confirm. Then in the manufacturing industry, you have automated processes like the warehouse robots that I was talking about. Then agriculture as well. AI has been used a lot in agriculture. I've worked in developing AI systems for agriculture in area of weed detection, poultry feeding, and the rest. Then in banking and finance, you can predict the stock behavior or forex behavior, and you can forecast how a certain market commodity will behave. Then in oil and gas, you can use AI to monitor pipelines, identify cracks or spillages in pipelines. So AI has many applications. These are not all the applications. These are just some of the ones that I brought out. And in this picture, you can see some diagrams that show us the multidisciplinary applications of AI. The first diagram here, we have a self-driving car that navigates the environment autonomously with nobody directing it. The second diagram up here is the vacuum robot that I was talking about that goes around the house sweeping and vacuuming. Then you have the surveillance drones here that can both navigate automatically with AI, but also the camera itself, it can identify something with the camera autonomously. It can pick up people, animals, anything you can think of. Then here you have the AI surgical robots, that give doctors insight, and some of them actually perform the surgeries themselves, but you can also use it for medical diagnosis. Then the fifth picture here is an example of an AI robot used in agriculture. And the last here, we have some AI robots that are used in the manufacturing industry. Are you still with me?
Yes, sir.
Okay, thank you. So now that we've talked about AI,
Yes.
let's talk about another component of AI, which many people associate with AI. Many people even interchange it with AI, but they are not interchangeable. They are not synonyms, but it's a component of AI, and that is machine learning. Now, in one of the subsequent classes, we'll discuss more about machine learning and talk about it in detail, and even maybe carry out one or two examples in the hand-on sections. But I just want to give you an idea of what it's all about so that you don't confuse it with AI when you hear them used separately. Now, unlike AI that was introduced by John McCarthy, machine learning was introduced by Arthur Samuel. And this field of study gives computers the ability to learn without being explicitly programmed. So in AI, you are trying to give machines this type of human intelligence. But machine learning, you are particularly focused on making the machine learn without telling it what to do. Now, let me give you an example. If today, all these young kids, if you show a young child a mango that is green, and that child has never seen a mango before, you show him the mango today, you show him the mango tomorrow, you show him the green mango next tomorrow, the child would learn and register in his head that this is a mango, this is what it looks like. Now, when the child tomorrow sees a yellow mango, now you have some categories of children, and not what some children might pick up automatically and say, even though this is yellow, this is still a mango. Some that are not sure would ask and say, but this thing looks like a mango and it's yellow. Is it still a mango? So more or less, that child has tried to learn to understand what a mango looks like. Now, if you explicitly program a computer to recognize a green mango, tomorrow, if that computer sees a green mango, it cannot tell you that, if tomorrow the computer sees a green mango, it will tell you that this is a green mango. If the computer now sees a yellow mango or a red mango, it will not tell you, it won't be able to identify that that is a mango, because you have strictly told it that this is what a mango looks like. It is green, it is this, it is that. But when you give computer information about the mango and the computer identifies some key features in the mango on its own, tomorrow, if the computer sees a yellow mango, it can tell you that this is a mango. Maybe you would have reduced accuracy or reduced confidence, but it will still be able to identify that that is a mango. So the computer performs these tasks based on past experiences it has learned, but not exactly how you program it to behave. Now, this learning process means that you need to develop what is called a model, and you use data to do that. So we'll look at some of those terminologies later, just to give you an idea on how these things work. Now, machine learning itself is categorized into mostly 4 parts. You have supervised learning, you have unsupervised learning, you have semi-supervised learning, and you have reinforcement learning. Now, for those of us that like cars, right? If I bring 5 cars, maybe one is Benz, one is Toyota, one is Honda, one is BMW, and the other is Ford, and I show you the logos of these cars, one after the other, and I tell you this logo that is round, it's a Toyota logo. This logo that has HO is a Honda logo, and so on. And I show you the logo and I tell you that this is what the logo represents. That is supervised learning. In supervised learning, you have the data, but each of the data represents a particular output or a particular class. So you are telling the algorithm that this set of data represents this class, this set of data represents this object, and this set of data represents that thing. So that is supervised learning. Now, examples of supervised learning techniques are artificial neural networks, support vector machines, decision trees. We'll look at those things later. Now is just to give you an overview of what they stand for. Now you have the unsupervised learning. In unsupervised learning, when I bring those cars for you, and I wouldn't tell you that this logo belongs to this or that. I'll just tell you, look at the logos of these cars and group them for me. So if you look at the Toyota logo, you see that this one looks a bit different. Let me keep it one side. It belongs to one category. You look at the Honda logo and you say, this looks different from the other ones. Let me put it in one corner. Then you do that also for the BMW. So if you have like 20 cars with those logos, you can put them in different categories based on their logos, even though you don't know what those logos stand for, but you know that, okay, because these two have similar logos, they must belong to the same family and so on. That is unsupervised. You have the data, but you don't know the classes or the targets. So you are showing, you are grouping them based on the features that they have. So that is unsupervised learning. And an example of that, one of the most common examples is K-means clustering. Now you have semi-supervised learning. As the word semi implies, it falls between supervised and unsupervised. So in this case, part of the data set has labels and some of the others do not. And in that case, you still need to, train the model using that data. More or less what you do is you use those labels that you have and generate labels that you don't have before you train the data with everything. Then you also have reinforcement learning. In reinforcement learning, I'll tell you to group the cars. If you do the grouping correctly, I'll say take 100 Naira. If you do something correct again, I'll give you 100 Naira again. So more or less in reinforcement learning, there's some sort of reward system that the algorithm will try to get a reward if it does something right, and it tries to get the maximum reward as possible. So that's just a basic introduction to machine learning. We'll look at it in depth in the subsequent workshops. Now, let's look at a few terminologies that, a few words, a few concepts that are used more or less in AI that we are going to be using a lot during the course of this workshop, this 5-week workshop. These terminologies are used a lot, so you need to have a basic, a fundamental understanding of what they mean, so that when you hear them, you can quickly relate to this is what they mean. Now, the first terminology that we have here is a model. Now, what I have on the slide is, it is a mathematical function that represents relationship between inputs and outputs. More or less, when we talk about models, we are talking about any AI technique that we've developed. If we've developed a technique in ANN, we'll refer to that as our model. If we've developed it in genetic algorithm, we'll refer to that as our model. Because more or less, that model can take some inputs and give you a particular output. So that is what we refer to as model. So when we are doing the workshops and you hear us saying model, we are basically referring to that AI technique or AI solution that we are developing to perform a specific task. Then you also have the machine learning algorithm. That is the specific machine learning technique that we are using, that we are training with our data. So if we are training any machine learning algorithm, we are using data to train it. So that technique that we are using to develop our model is the machine learning algorithm. Then you have an algorithm. Basically, what an algorithm is a step-by-step process of solving any problem. That is what an algorithm is. If you wake up in the morning and you want to go to the classroom, and you decide that, okay, I'm going to wake up, I'm going to say my prayers, I'm going to take my bath, I'm going to dress, I'm going to have breakfast, and I'm going to walk to the classroom, you've already developed an algorithm, since you've already outlined a step-by-step process on how you want to get to the classroom. So the process that we take in developing these models, do this, do that, that is our algorithm. Now, another set of terminologies that you need to take note of is, the first one is data set. Now, when it comes to machine learning, you have to teach the algorithm. You have to give it data so that it can learn from that algorithm. Just like human beings, if you are being taught to identify a ball, if you see a red ball today, you see a blue ball tomorrow, you see an oddly shaped ball next tomorrow, after you've seen many balls, at some point, anywhere you see a ball, you can say that, okay, this is a ball. So our data set is a collection of data, mostly that helps the machine learn. That's what the machine would learn from in terms of machine learning. Now, when you have that data set, you can split it into 3 major parts. You have the training, the testing, and the validation. In training, more or less, you are teaching the model how to identify these things with the data. You are telling the model that if you look at this, so this is what it represents. If you look at this set of data, or this is what it represents. In testing, it's more or less like your examinations. You are just giving the data to the model and telling it, okay, I've already taught you this thing, see this data, tell me what each of these data represents. That is what testing is about. Then in validation, you've trained, you've tested, you just use some of the error values to fine-tune the model and make it perform better. So it's just like, okay, you've learned something in class, that is the training. then you do the test, you take a test, then that is the testing. Then after the test, the lecturer comes to the test and does some corrections. That is the validation. Are you still with me?
Yes, sir.
Okay.
Yes, we are with you.
We are still with you, sir.
Okay, so the last thing that I want us to look at is a quick guide to AI applications. Now, what I have here, more or less, is we know now we've understood what AI is, but AI itself is broken into different aspects. And based on what kind of problem you have, that is the kind of AI technique that you are going to employ. And I'm just going to give us a background on what I'm referring to here, because of course, after the workshops, what would be expected is our interns, our RAs, our students, even some of our faculty members would want to implement these AI techniques in some of their works, maybe academic and research, maybe you are building something, you're developing a solution. So you need to have an understanding of where you need to apply some of these AI techniques. Now, what I have here is I've grouped AI into 4 major aspects. You have the decision-making part, you have the optimization part, you have the machine learning part, and you have the deep learning part. Now, I'm not going to go into detail of what all these means, but I'm just going to give you an overview so that you can understand, and you can subsequently, when you want to develop a solution, you can always refer back to this and think whether it applies to which part. Now, the first part is decision making. Sometimes you'll be confronted with a problem that you want to develop a solution for, right? Somebody will come to you and say, I want you to do something for me and I just want AI inside. Now, it is left for you to decide what kind of AI you are going to put. Even if the person makes recommendations, you can always, based on your knowledge, tell the person that this would not work. Now, for decision making, let me give you a scenario. You have a room that you want to control the temperature, maybe with your fan or with your AC. Let's take the AC, for instance. You want to automate the AC process such that if the room becomes hot, the AC should come on and the room should become cold again, right? Now, in that kind of case, what you need is an AI technique that can sense the input, take a decision, and give you a particular output. Because you want the AI to take in the temperature, analyze the temperature, and then give you a value for the AC that will make the AC work. So in that kind of situation, you want the AI to take a particular decision. Now, in that kind of case, it's a decision-making problem. And one of the easiest algorithms you can implement in AI for decision-making is fuzzy logic. So in decision-making techniques, more or less, you need to implement a decision-making algorithm, and fuzzy logic is one of the most common ones. Another example is maybe you are automatically pumping water into a tank. And if the tank is full, you want the water to stop coming in. In that kind of situation, it's a decision-making technique. You take in an input, which is the level of the water, then you take a decision, then you give an output, which is the opening or closing of a tap. That is decision making. Or even the automated door at the supermarkets that we talked about earlier. You sense something and then you take a decision by opening the door. That is decision making. Now you have another aspect of AI, which is optimization. Now in optimization, optimization deals with a lot of mathematics, but the gist of it is you want to choose a best solution out of a range of possible solutions. Now, in this optimization, basically what you have is you have a criteria that you want to meet. And the AI technique needs to give you the best decision based on the criteria that you want to meet. Let me give you an example. If you want a robot to move from the Senate building or the admin block to, let's say, the school gate, If you have a criteria that, okay, I want the algorithm to take the shortest destination to the school gate, then you now have an optimization problem because you want the shortest destination, you have a criteria. Or if you want the lowest energy consumption, then you now have an optimization problem. You have a criteria. If you want a path that the algorithm will meet the lowest of obstacles, you now have a criteria that you want it to meet. If you want the minimum error value, you now have a criteria. In that case, that is an optimization problem. So in that case, you now have to think of an AI technique that is an optimization-based AI technique, because you have to define the criteria before you can implement the AI technique. Now, what if you have data, lots of data, and you want the AI to act based on the data? Let me give you an example. Maybe you have a lot of pictures of students, and you want the AI to select which student is which based on these pictures. Now you have data that you feed the AI. In that case, if you have data, then you look at machine learning or deep learning. Now, for machine learning, you might not necessarily need a lot of data, but for deep learning, you would need a lot of data for it to train. Another example is maybe you have medical information. You want to perform a diagnosis. You want your algorithm to identify if a person has diabetes or not, if a person has malaria or not, and you have data to support that. Then in that case, decision making and optimization AI don't necessarily need data to operate. In that case, you have to start thinking of machine learning. If you want to predict the stock market based on data that you have, then you now start thinking of machine learning and deep learning. If you want to predict the weather condition based on previous data, you have to start thinking of machine learning and deep learning. As long as what you have is data oriented, then you start thinking of these ones. Now, for machine learning itself, you don't need a lot of data, but one of the challenges with machine learning is that you have to specify the representation of the data. More or less, your data has to be a vector, either in one row or one column. But for deep learning, in things like convolutional neural networks, that's the CNN you see there, and you only look once, you can actually represent the data as a matrix. And that is why it is most popularly used in images, because you can represent the data as a two-dimensional set of numbers. So if you can represent the information in 2 dimensions, then you can use deep learning and convolutional neural networks for that. So subsequently, in subsequent classes, we're going to see how we can implement a few of these algorithms, both theoretically and also in the hands-on sessions. So this is an introductory class, and we are going to stop here for now. Thank you very much.
الصلاة والسلام على رسول الله وعلى آله وصحبه أجمعين. سبحان